Image of a person holding a scanner and tablet in front of items on a shelf. Other shelves with items are visible in the back. Figure 14. 1. As businesses grow, they often need to use more advanced features in Microsoft Access for complex database design and querying to help with tasks like managing inventory. Credit modification of man in black and gray plaid dress shirt holding black smartphone by Tiger Lily /Pexels, CC0. Chapter outline. 14. 1. Advanced queries in Microsoft Access. 14. 2. Multiple table forms. 14. 3. Customizing forms. 14. 4. Customizing reports. 14. 5. Using macros. 14. 6. Data analysis and integration. Now it is time to discuss advanced database applications at WorldCorp. As you continue to grow with the company, we will expect you to dive deeper into what is possible with data analysis. Your role will continue to advance as an analyst working with data professionals supporting various teams within WorldCorp. WorldCorp wants to grow and expand into its independent retail locations to better serve its vast customer base. It still needs to create a database to manage inventory for these new locations. This would involve more complex database design and querying, as well as the use of advanced features in Microsoft Access. First, we want to determine the data WorldCorp might need to store. We can start by identifying the key elements to track potential product names, SKU numbers, locations, quantity on hand, and likely reorder points, and designing a table structure to best serve each type of data. For example, you could create a products table with fields for product name, SKU number, description, and unit cost, as well as a locations table with fields for location name and address. WorldCorp would need a user interface to enter the data for each product and location into their respective tables. We will walk through some advanced steps in Access queries to retrieve specific sets of data from specific tables. For example, a query to find all products with a quantity on hand below the reorder point, or to find all products located in a specific store. You will also learn how to create reports to help keep track of inventory by summarizing and displaying data in a user-friendly format. For example, you could create a report that shows inventory levels by location, or one that shows sales trends by product category. Learning objectives. By the end of this section, you will be able to create a query with multiple criteria, create queries that use operators and expressions, design queries that select aggregate and run actions. As your database continues to evolve, the incorporation of advanced queries aids in the management and manipulation of the exact data of interest. For example, at WorldCorp, you might need to collect all types of information on customers, e.g., email, phone, address, demographics, shopping history. This information often needs to be stored across multiple tables for both speed and efficiency. As an example, a new customer's basic information will be stored in one table. We assume this information doesn't change often, only when the customer moves to a different location or makes a major life change. In addition to contact and location, basic information could include demographic information, which may never change in our records. In a separate table, we would store a record of each time the customer makes a transaction. Transactions may happen often and are usually unique, as each one has a particular time date, exact location of purchase, and possible coupons or rewards points added. Additionally, a customer's purchase may be for a single item, several items, or perhaps 100 or more different items. Think of a trip to the grocery store on the same transaction. By using an advanced query, you can isolate both customer information and purchasing information at the same time from both tables. For example, suppose you want to know how many customers shop for a particular service or item at locations at least 20 miles from their homes. Determining this would require enforcing multiple criteria across multiple tables and using advanced features in query design to find the exact data requested. The design tools available in Access allow for this level of advanced database design and function. Queries with multiple criteria. A query criterion is a kind of formula used in Access to filter the records based on values in fields of interest to determine whether to include the record in your query results. Criteria may take the form of a number, full or partial text, or any combination of data points within a table such as red or equals 5. You can include criteria for each field as shown in Figure 14. 2. Only items that match all the criteria you enter will appear in the query results. Connected queries T customer order and T customer order detail are shown. A spreadsheet shows rows, field, table, total, sort, show, criteria, or and columns, order ID, order date, notes, price, QTY, order. Prince asterisk QTY, criteria and or rows are blank. Figure 14. To access data can be filtered and sorted using criterion such as customer or order date. Used with permission from Microsoft. Types of criteria. Listed are the different types of criteria that can be used in an access query. Simple criteria. This type of criteria involves specifying an exact value or expression to filter the results. For example, when building out the inventory database for our potential freestanding retail locations, you could use simple criteria to specify which exact type of inventory you want to isolate. Comparison operator. Comparison operators are used to compare two values or expressions. Examples include equals and greater or equal. The operator can be helpful to find out what inventory has less than a specified quantity on hand. Wildcard. Wildcards are used to represent unknown characters in a search string. The two most common wildcards in Access are the asterisk, asterisk, and the question mark. For example, a wildcard can be used to find all customers whose last name starts with a particular letter. Table 14. 1 shows the most common wildcard symbols and a description of how they can be used when you have incomplete information or unknown characters. Symbol description example. Identifies 0 or more characters, often used as the first or last character in the character string. Ba finds ba, bat, ball, and balloon, finds any single alphabetic character. WLL finds will and well. Matches any character found within the brackets. TAEM finds tam and tem but not tim, identifies all characters not in the brackets. B. AID finds bed and bold but not bad or bid. Ties any one of a range of characters. Users must specify the range in ascending order A to Z, not Z to A. CACT finds cat, CBT, and CCT. Finds any single numeric character. 5-4 finds 504, 514, and 524. Table 14. 1. Wildcard characters. Wildcard characters are useful when filtering where data could lack uniformity or you have incomplete information. Range criteria. Range criteria are used to specify a range of values for a field. As an example, a vendor that we buy from to resell in our new retail locations may want to know all of the orders we have sold of theirs within a specific date range that have been taken out of our inventory. Rather than waiting for our next order, our vendor could receive critical information on how much we may be looking to order in the near future. Null criteria. Null criteria are used to find records that have a null value in a particular field. For example, you could use null criteria to find any inventory labels that do not include product descriptions. Logical operator. Logical operators are used to combine multiple criteria in a query. The two most common logical operators in Access are AND and OR. For example, you could use the AND operator to find all orders with a total greater than $100 and placed by a specific customer. Table 14. 2 summarizes common logical operators. Logical operator description example. And returns true if both operands are true and false otherwise. It is represented by the symbol AND. Quantity 100 and location equals Philadelphia. Or returns false if at least one of the operands is true and false otherwise. It is represented by the symbol. Quantity 100 or location equals Philadelphia. EQV returns true if both operands are either true or false and false otherwise. It is represented by the symbol less or equal. Quantity less or equal 25 or location equals Philadelphia. Not returns true if both operands are false and false otherwise. It is represented by the symbol. Not quantity 10 or location equals Philadelphia. XOR returns true if exactly one of the operands is true and false otherwise. It is represented by the symbol. Quantity 10, quantity 100. IMP returns false if the first operand is true and the second operand is false and true otherwise. It is represented by the symbol. Location equals Philadelphia. Quantity 100. Table 14. 2. Logical operators. Logical operators are used often with databases to allow you to filter information with multiple criteria such as several locations, specific customers, or non-contiguous date ranges. By using these different types of criteria in an access query, you can create powerful and flexible queries that can help you analyze and manipulate your data effectively. Figure 14. 3 displays a few sample criteria shown in the highlighted box and explains how they work with operators. Rows labeled field, table, total, sort, show, criteria, or, and columns labeled ordered, order date, notes, price, QTY, order. Prince asterisk QTY, visible, filled with information. Criteria row and order date column cell with date, -1 is highlighted. Figure 14. 3. When delimiters are used to filter a database, you will notice the criteria listed under the field column. Used with permission from Microsoft. At WorldCorp, you may need to isolate orders that took place during a certain time frame. For example, how did our marketing campaign do in sales over a particular time period for our retail locations? How many orders did we do over the past week? How many did we do over the past month? You might need this information to help schedule orders for our retail locations. This example returns items with yesterday's date 1. Thus, if the current date is 5/12/2024, you will see only items for the previous day, 5/11/2024. In addition to the date function, there is also a now function to consider in Access. Both date and now are used to retrieve the current date and time, but they have different purposes and applications. The date function returns only the current date without any time component. It is useful for calculating dates and time intervals, such as the number of days between two dates, or for filtering data based on a specific date. On the other hand, the now function returns both the current date and time, including the hours, minutes, and seconds. It is useful for tracking events that occur at a specific date and time, such as recording the time that a delivery showed up in inventory at a retail location. Some reasons why you might choose to use the now function instead of the date function in Access can include the need to record timestamps. If you need to keep track of when events occur, such as the time of day when items are most likely to sell, the now function can be used to record the timestamp accurately. In addition, if you want to filter records based on a specific time range, such as all transactions that occurred within the last hour, then you will make use of the now function. In designing tables, note that it is important to use the correct format for each field used in the table you are pulling from in the query so that the unique expressions can be applied to that field. In the example shown in Figure 14, 4, the field labeled order has a criterion of less than 50, so you will see only amounts that are less than $50 from what our customers spent at WorldCorp. The amount found in this field is calculated by multiplying two fields, price and QTY, and grouping the results by sum for a total of all unique order ID numbers. Greater than, less than, equal to equals, greater than equal to equals, less than equal to equals, and other mathematical expressions can be used to query all fields that are formatted as numbers, including currency, integers, autonumbers, and calculated fields. Rows labeled field, table, total, sort, show, criteria, or, and columns labeled ordered, order date, notes, price, QTY, order, prince asterisk QTY, visible, filled with information. Criteria row and order, prince asterisk QTY, column cell with 50 is highlighted. Figure 14. For a logical operator is used for order price to only display orders that are less than $50. Used with permission from Microsoft. In the example shown in Figure 14, 5, the notes field in a query is based on a table that stores notes from sales orders that are formatted as long text. A note can contain any amount of text, ranging from no words to a few words or even multiple paragraphs, depending on the order and the customer's requirements. This criterion isolates all notes that contain the string express, signifying the customer's urgent need for the product. The keyword express can be extracted from all of the text logged in the notes field, regardless of the order or length of the note. Rows labeled field, table, total, sort, show, criteria, or, and columns labeled ordered, order date, notes, price, QTY, order, prince asterisk QTY, visible, filled with information. Criteria row and notes column cell with like asterisk express is highlighted. Figure 14. 5. Notice the asterisk following the word express as a wildcard to filter the data where the word in any form appears in the notes section. Used with permission from Microsoft. Depending on how you format the data, your next task is to select the appropriate expression to extract the data. Yes, no, OLE objects, hyperlinks, and attachments all have unique expressions to help optimize Access's ability to match your desired outcome. Again, formatting the data within tables is key to developing successful criteria expressions. Building a query with criteria. When you create or modify a query in Access, you will be identifying creating fields of data to isolate. These fields will represent the data you want to include, omit data that is not of interest to you, sort the data, and even combine data from multiple tables, as Figure 14. 6 shows. 2 connected queries: T customer order, order ID, order date, notes, and T customer order detail, QTY, and price, with corresponding locations in the field columns on the list: order ID, order date, notes, price, QTY, order. Prince asterisk QTY, shown by double arrows. Figure 14. 6 several layers of filtering can be used in one query to build a customized list to meet specific needs. Used with permission from Microsoft. The example shown in Figure 14. 6 of a query at WorldCorp combines 2 tables and isolates 5 fields from the related tables. The tables are related by the order ID field. When a new order comes in, a unique order ID is created in the T customer order table. Then, the order details are created in the T customer order table. The 2 tables are related by order ID. This means that every order can have multiple sales items on the order. In short, every order is uniquely related to a customer. However, every order can have multiple sales items on the order. Those items are stored as a list in a separate table. Every customer, every order, and every list of order details need their own tables. This example's 5 fields to review are order ID, order date, notes, price, and QTY. Because running this query would yield every order, it may not be useful unless you create criteria to isolate a particular question. Within Query Design tab, choose the column of the field to which you want to apply a criterion. Click in the box below the field name in the criteria row for that field. Type in your first expression or right-click in the criteria box and choose Build to utilize the criteria wizard. Repeat these steps for each field for which you want criteria that help answer the question at hand. For instance, if you are concerned about offering free next-day shipping on all orders because of the rising costs of shipping, you might want to look at low-dollar purchases to see how often customers are asking for express shipping. One option is to review only those orders from yesterday, criterion 1, that were less than $50, criterion 2, and also had the string express in the notes, criterion 3, on the receipt. The following criteria would be typed out or built through the wizard for each field highlighted in order as Figure 14. 7 shows. 2 queries: T customer order, order ID, customer ID, order date, notes, and T customer order detail, detail ID, order ID, stock item ID, QTY, price, visible. Cells populated in criteria row with date, -1 order date column like express, notes column, and 50 order, price asterisk QTY column. Figure 14. 7. The criteria wizard can assist you in building a more complex query, or you can also type criteria directly into the query if you are familiar with the appropriate syntax needed. Used with permission from Microsoft. Link to learning. Have you ever wondered how books made into movies do in theaters? And if it is a series of books such as Harry Potter or The Hunger Games, which book movie is more popular? Databases can be used to find out these answers. The power of a relational database lies in its ability to efficiently manage and organize large amounts of data in a structured and flexible way. To find answers for a person, an organization, or society as a whole, data needs to be processed in a way that helps transform it into useful information. To learn more, watch this video discussing how to build a query with basic criteria using data points using the Harry Potter movies for reference. Using operators and expressions. As you develop an inventory system for WorldCorp's future retail locations, inventory becomes tied with POS point-of-sale systems. The actual sales amount for each inventory item has not been calculated yet. Taxes, discounts, and price corrections all have to be considered for a total. Expressions become an important element to know and understand. You might want to use expressions to create a formula to calculate a total order amount. The order amount is calculated by multiplying the price per item in stock to the quantity ordered of each item. As discussed in the previous example, or any number of other requests, if the number can be calculated, there may not be a need to store it in a table. In the previous example, the field order has no associated table syntax is important to consider and be aware of when writing expressions in Access, because it defines the rules and structure for how the expression is written. The set of rules by which the words and symbols in an expression are correctly combined is called syntax. Access uses a specific syntax to understand and interpret expressions, and any deviation from that syntax can result in errors or unexpected results. Proper syntax ensures that the expression is written in a way that Access can understand and process it correctly. It helps to avoid errors such as syntax errors, calculation errors, or incorrect results. Additionally, consistent use of syntax can make the expression more readable and understandable to other users or developers who may need to review or modify the expressions you create in the future. Overall, understanding and using proper syntax is crucial for writing accurate and efficient expressions in Access. See Figure 14. 8. Many of the expressions that are used in tables and forms are also applicable to writing building expressions as criteria in queries. An expression is a combination of operators, identifiers, functions, and constants that are used to perform a calculation or to produce a result. An expression can be used in a variety of contexts, such as in queries, forms, reports, or macros. 4 boxes pointing to the word expressions, operators plus, asterisk, greater or equal, identifiers form, FRM order, date out, reports, RPT sale report, total sale, QRY sales. Amount, constants 1978-19709 OH, Sarah 12% and functions sum, AVG, date, len, now, Figure 14. 8 through expressions, you can restrict queries based on text, numbers, and also perform functions. Used with permission from Microsoft. To be a valid expression in Access, an expression must contain the following elements. Values. Every expression must contain constants that include one or more values, such as a number, string, or date. Values may be constants, which are entered directly into the expression. Values may also be retrieved from fields or controls in a table or form. Operators. Operators are required symbols or keywords used to perform mathematical and/or logical operations on values. Functions. Functions are predefined calculations or operations that can be used in an expression, but are not required. Access includes a wide range of built-in functions to perform such tasks as calculating totals, formatting values, and manipulating text. Parentheses. Parentheses are used to group parts of an expression and control the order in which calculations are performed. Following the rules of mathematics, expressions within parentheses are evaluated first. Identifiers. Identifiers are names used to refer to tables, fields, and other objects in an Access database. Identifiers must follow specific naming conventions, such as not containing spaces or special characters, and must be enclosed in square brackets to work within expressions. Commas. Commas are used to separate multiple arguments in a function or expression. In addition to containing these elements, keep in mind that correct syntax is established and maintained. Understanding operators and expressions. The two most common logical operators used in building an expression for criteria in a query are AND and OR. These are assumed depending on where you place the expression in query design. Any expression placed in line with the criteria line is defined as an AND operator. Our last example used all AND operators for the 3 expressions. See Figure 14.9 as an example. Screenshot of a table with criteria row with date, -1 dateout column, 50 amount column like express, notes column populating the cells. Figure 14. 9 by default, when criteria are added to more than one field, those criteria will be used simultaneously in the query using the AND operator. Used with permission from Microsoft. Placing all three criteria on the same line means that the query will display only those items that are from yesterday and are less than $50 and contain the string express. If you want the query to look for any of the three criteria, that is yesterday or less than $50, or containing the string express, each needs to be on a separate line. Date -1 would be in the criteria row, 50 in the or row, and then place like express in the row below the or row. Rather than a dataset needing to match all three criteria or to match either of the two requirements, it can now match any of the criteria. Any expression placed below the criteria line is then defined as an OR logical operator. If we change our last example by rearranging the placement of the expressions, it operates very differently, as Figure 14. 10 shows, screenshot of OR row with 50 amount column and like express notes column populating the cells. Figure 14. 10 to query using the OR operator, the selected criteria should be moved one line below to the OR line used with permission from Microsoft. Placing the second and third expressions on the line below the first criterion means that the query will now yield those items that are from yesterday or are less than $50 and contain the string express. Rather than a dataset needing to match all three criteria, it now needs to match either of the two requirements. Common operators. In both Excel and Access, the most common operators are arithmetic, comparison, and logical. Each has its own function and returns different results. An arithmetic operator is used to calculate a value from two or more numbers, or to change the sign of a number from positive to negative or vice versa. Table 14. 3. Operator description. Subtraction 2-1 equals 1. Multiplication 2*3 equals 6. Slash division 12/4 equals 3. Backslash integer division 6*4 equals 1. Plus addition 15 plus 4 equals 19. Table 14. 3. Arithmetic operators. A mathematical operator could be used to combine data such as getting the total sales amount for two or more company purchases. A comparison operator is used to compare values and return a result that is true, false, or null. Table 14. 4. Operator description. Less than, less or equal to, not equal to, equal to, greater or equal to, greater than, between value 1 and value 2, between two values inclusive. For example, between 1 and 3 would return 1, 2, 3. Table 14. 4. Comparison operators. To compare one customer's sales to another, you can use comparison operators such as greater than or less than. A logical operator is used to combine two Boolean values and return a true, false, or null result. There are three main logical operators that are commonly used in Access. AND operator. This is used to combine two or more expressions and returns true only if all the expressions are true. For example, the expression sizes 8 and color equals blue will return true only if the size of a shirt is greater than 8 and the color is blue. Or operator. This is used to combine two or more expressions and returns true if any one of the expressions is true. For example, the expression size 8 or color equals red will return true if either the size is greater than 8 or the color of the shirt in inventory is red. Not operator. This is used to reverse the logical value of an expression. It returns true if the expression is false and false if the expression is true. For example, the expression not size 8 will return true if the size of the shirt is less than or equal to 8. These logical operators can be used in combination with comparison operators such as equals, a less or equal, greater or equal, and to create complex expressions that evaluate to true or false. Table 14. 5. Operator description. And both elements of an expression must be true, not the expression must evaluate as false, or at least one element of an expression must be true. XOR exactly one element of an expression must be true, not both. Table 14. 5. Logical operators. Queries that filter using several layers might involve logical operators to extract information from a large database. The next example, shown in Figure 14. 11 is a query designed to help create a report. In this case, you need to generate an invoice after a customer places a new order with WorldCorp. Invoices for customer sales include items such as the customer information, the date, the products ordered, price for each product, and total for the entire invoice. Refer to the chapter on advanced document preparation for examples of invoices. For the report to work properly, two different criteria must be used with the logical operator and the first expression is forms. FRM outbound to document, which uses identifiers to isolate which document number the report will generate. In essence, this expression uses identifiers to query only the exact document number that is in use on the FRM outbound to form, which is used to place all new orders from customers. By identifying the form number, the invoice will generate the exact order and only the called-upon order. Queries TBL customers, TBL outbound, TBL customer order detail, QRY stock, TBL state, TBL city with criterion listed underneath, visible with table below. Table rows labeled field, table, sort, show, criteria, or, and columns filled with information. Figure 14. 11 Access not only lists the fields in text, but also provides a visual representation of how elements are connected in the database. Used with permission from Microsoft. The second criterion is a function expression that isolates the order date to today, and today only, ensuring that the query only creates new invoices that represent new orders from today. See Figure 14. 12. Queries TBL stock, TBL shirt style, TBL shirt size, TBL shirt graph, TBL shirt colors highlighted, display in field row column 2 as item. Style and color and graphic and size and criteria row as hoodie style, XL size green color and or row as red color. Figure 14. 12. Notice how several fields are used to perform the query using logical operators. Used with permission from Microsoft. This example shows a query designed to help show which items a t-shirt design company has in stock. Each stock item has 4 fields that collectively describe the piece of clothing: style, size, primary color, and graphic design on the item. In this example, a customer wants to know what graphic designs are available on a hoodie that is size XL and has a base color of green or red. These criteria combine both constants and logical operators to help isolate the data requested by the customer. Guidelines for using criteria. There are best practices to follow when using criteria. Keep it simple. Do not try to do too much with any one query to get an answer. A query can do a great deal. One strategy is to copy previously designed queries and rename before making small changes to each copied query for a very specific purpose. To stay organized, be consistent in how your queries are named. When you first learn the syntax used in creating criteria, it is tempting to try to use all of the syntax in a single query. When creating a query, however, it is more important to keep the main purpose of the query in mind. If you have several questions, don't be afraid to create multiple queries, a separate one for each question or task. Be sure to create tables carefully, using the correct format for each field within each table. Using good naming practices is important. A key reason that queries won't run is likely to be the formatting of the fields rather than incorrect syntax. Develop a list of expressions that you know and can use for future projects. Often, these can be repeated in various queries for various uses. Designing queries to run actions. Now that you know how to build a query, let's look at the different types of queries in Access. There are 5 types of queries, each with a unique function and use. 1. Select queries, 2. Action queries, 3. Parameter queries, 4. Cross-stub queries, and 5. SQL structured query language queries. Select query is the most common type of query and the easiest to use. They retrieve data from one or more tables and display the result in a datasheet. Select queries are also used to group records and calculate averages, sums, counts, and other types of totals. As an example, a select query might be used to group customers by state to see which states have the highest demand. Action query specifies a particular action, such as creating a new table, deleting rows, updating records, or creating new records. Action queries are very popular in data management because they allow for many records to be changed at one time. For example, suppose you need to update your records to reflect a new state tax rate that affects numerous types of transactions. Creating an action query can help update records across various tables. There are 4 types of action queries: append query, Adds records from one or more tables to the end of one or more tables. Update query. Makes global changes to a group of records in one or more tables. For example, you can use an update query to increase the prices on your menu by 25% for products within certain categories. Delete query. Deletes a group of records from one or more tables. For example, you can use a delete query to remove products that have been discontinued or for which there are no orders. Make table query. Creates a new table and populates it with data from one or more existing tables. When you create a make table query, you specify the fields and criteria that you want to include in the new table. Access then creates a new table and copies the selected data from the existing table S into the new table. The new table will have the same field names and data types as the original table S. These queries can be useful in a variety of situations, such as creating an archive or backup of data. You can use a make table query to create a backup copy of important data before making changes to it. In addition, simplifying complex data can be very helpful. As an example, if you have a table with many fields or complex relationships, you can use a make table query to create a simplified version of the data that is easier to work with on a different project. Also, aggregating data can be accomplished. You can use the query to aggregate data from multiple tables into a single table, which can be useful for reporting or analysis purposes. Parameter query is a type of query that prompts the user for input values when it is run. The input values are used to filter the data that is returned by the query, based on the specified criteria. Parameter queries are useful when you want to create a query that can be easily customized to return different results based on specific criteria. For example, this query can be used in building a form that asks users which employee is logging into the main menu screen to start a transaction at WorldCorp. You type which user on the criteria line. When the query runs, Access will prompt the WorldCorp employee for the answer to your question. CrossDeb query calculates and restructures data for easier analysis when looking for trends or patterns. Much like the pivot table option in Excel, CrossDeb queries calculate a sum, average, count, or other type of total for data that is grouped according to two different types of information. For example, total sales for WorldCorp might be grouped in two ways: by salesperson, listed down the left side of the datasheet, and also by month and year, listed across the top of the datasheet, which now shows total sales for each salesperson by month and year. SQL query is created by using an SQL statement. When you create a query in Query Design View, Access builds the equivalent SQL statements for you behind the scenes. You can view or edit the SQL statement in SQL View. Upon viewing any of the created statements by Access, you can edit or add to the statement. This creates additional options for you that are often more efficient than using the Query Design View options. Building a query that aggregates. Aggregate query lets you carry out calculations on record groups rather than performing individual operations. An aggregate query considers the total, subset, or gross amount of records. Aggregation is a powerful tool because of the nature of relational data. By looking across the connected tables and through the built-in relationships, these can be accounted for when performing complex data searches and totals among a vast area of applications. Often, the first step in building an aggregate query is to turn on the Totals tool that is found within the Query Design tab, as seen in Figure 14. 13. Screenshot of Query Design tab in Access selected, with totals highlighted on the toolbar in the Show Hide command group. Figure 14. 13. The Totals tool is found in the Show Hide command group when you are designing a query, used with permission from Microsoft. After you select Total from the menu, a new row labeled Total appears just below the field names, with an option area in the Access query, as seen in Figure 14. 14. Screenshot of a total row with a drop-down in the cell with options for Group by Indicated, Sum, AVG selected, Min, Max, Count, CintDev, var, First, Last, and Expression. Figure 14. 14. Although the word total is used, you can choose to get values other than just the sum of the numbers, such as the average or the maximum number in the field. Used with permission from Microsoft. The default option is Group By, which groups all identical data items in the field. For example, if you wanted to know which stock item in your company's inventory sold the most units, you could use the stock ID in two ways. Create a field for stock ID in the query and list the totals as group by. This will provide a list of each type of item you have sold. Create another field also with the stock ID, but this time, choose the sum function of the total to provide a complete sales count for each unique item. Both fields together provide a report on which items have sold the most and the least. Examples of aggregate queries. Scenario 1, you have an online business that has customers from around the country, and you want to find out which states have the fewest customers. You decide to create an aggregate query to summarize the list of states and count the number of instances in which each state appears among your current customers. Selecting the totals option creates the following query from the customer table, as figure 14. 15 shows group by state name and count state name. Queries TBL customers, customer ID, first name, last name, email, phone number, address, city ID, state ID, zip, notes, and TBL state ID, state abbreviation, state name are displayed in table with state name drop-down highlighted in field row. Figure 14. 15. This query will give a summary of the total number of customers in each state using the count operator, used with permission from Microsoft. Scenario 2. You receive 2 free tickets to the Super Bowl. Unfortunately, you cannot attend this year's game, so you want to give the tickets away as a thank you gift to the customer with whom you have done business the longest. To determine the recipient, you decide to do an aggregate query on customer orders, using date ranges to identify the longest standing customer. The following aggregate query, shown in figure 14. 16, is then created by grouping the customer ID, using dateout as the minimum total first order, and then using dateout as a maximum total to establish the last sale the customer made last order. Queries TBL customers, customer ID, first name, last name, email, phone number, address, city ID, state ID, zip, notes, and TBL outbound document dateout customer notes are displayed in table with fields for customer ID first order. Dateout, last order, dateout, figure 14. 16 more complex queries can be constructed to compare dates or other fields using the total tool, used with permission from Microsoft. In this scenario, it would be best to build an additional query to calculate the length of time between first order and last order, as determined in the original aggregate query. The query has to solve both totals before it can calculate the difference in time between the two fields using the min and max functions. Learning objectives. By the end of this section, you will be able to create a form that uses data from 2 different tables. Create a form that contains subforms. Much like any global manufacturing corporation, we have an extensive list of assets that include company vehicles, equipment, and facilities to operate and manage. At WorldCorp, when you work with relational data, it is often convenient to be able to view multiple tables on the same form. For example, suppose you are reviewing a fleet of vehicles for one of our manufacturing facilities in Germany. Initially, you built a form that lists all the vehicles in use and enables you to add and subtract vehicles. You also built a form to create service records for each vehicle that WorldCorp owns. When a new vehicle is added to the fleet, it receives an initial oil change and fresh fluids, and these service records are logged. You want to create a form that will make it easy to add a new vehicle and simultaneously add the initial maintenance and repair notes for that vehicle. To do this, you need to add a vehicle to a list of fleet vehicles on one table, and at the same time, add information about the maintenance repair that has been done to the vehicle on another table. To accomplish this goal, you may want to combine data from 2 tables in one form or create subforms. This section presents several methods to help you create advanced forms. Adding data from 2 tables in a single form. If you want to add data across multiple tables in one form, this could help with efficiency when managing a fleet of vehicles at WorldCorp. Primarily, it can speed data entry while maintaining the organization of tables, fields, and records. To effectively create forms that feed into multiple tables, you should use a query as a critical building block. Recall from the chapter on understanding and using databases that a query is an access object used to view, analyze, or modify data. The query design determines which fields and records you see and their sort order. Using the example of our manufacturing facility fleet vehicle program, you can review how the query is designed, how to adjust it for user experience, and how to use the form wizard to build a form that can add data to two tables. Using queries for a form. First, a query needs to be designed to build a relational database for the fleet vehicle program. In this example, you have two tables of information, as seen in Figure 14:17. TBL vehicle and TBL maintenance. TBL vehicle forms with columns field name and date type, both containing information in cells, and TBL maintenance form with columns field name and date a type, highlighted yellow, both containing information in cells. Figure 14:17 forms are used in a variety of ways in organizations, and using Access collects the data automatically into a table. Used with permission from Microsoft. The TBL vehicle table represents each unique car truck the company owns. The TBL maintenance table represents every maintenance record, oil changes, new tires, chipped glass repair, inspections, etc. on all vehicles. In this section, you will see how to design a form that can add information to both tables simultaneously. Remember that the ultimate goal of the new form is to add a new vehicle to the fleet, and to include that vehicle's initial service information, oil change, safety inspection, cleaning, company decals, etc. So that WorldCorp does not lose track or misuse valued assets. The new form will serve as a quick form for all new vehicles. For the query to be effective, a clear relationship needs to be established between the two tables. In this example, vehicle ID is the primary key of TBL vehicle and is listed as a required field of TBL maintenance. Recall from the chapter Understanding and Using Databases that a primary key is a field or set of fields with values that are unique throughout a table. Values of the primary key can be used to refer to entire records because each record has a different value for the key, as shown in Figure 14:18. TBL vehicle and TBL maintenance forms visible. Data type in VehicleID opens to option pane includes short text, long text, number, large number, date time extended, currency, auto number, yes, no, hyperlink, lookup wizard highlighted, etc. Figure 14:18 similar to defining the number type in Excel. When you create fields, you can determine the type of information in that field. Used with permission from Microsoft. Access provides different data types for formatting field names. Rather than setting the vehicle ID field in the TBL maintenance to short text, autonumber, or number, you can use the lookup wizard to build a relationship between tables. The example shown in a series of screenshots, Figure 14:19, Figure 14:20, Figure 14:21, Figure 14:22, Figure 14:23, and Figure 14:24 will walk through the use of the lookup wizard steps that are used to create a relationship. Lookup wizard window lists options for I want the lookup field to get the values from another table or query, selected indicated, and I will type in the values that I want. Figure 14:19 the lookup wizard can be used to create fields in a table in a step-by-step fashion either from an existing table or you can create a new table. Used with permission from Microsoft. Lookup wizard asks which table or query should provide the values for your lookup field. Table, TBL maintenance and table, TBL vehicle selected display. Tables button selected from view options including queries and both. Figure 14:20 if you choose to pull fields from an existing table in the database, you will need to identify the specific table. Used with permission from Microsoft. Lookup wizard asks, which fields of TBL vehicle contain the values you want included in your lookup field? The fields you select become columns in your lookup field. Selected fields. Year selected, Figure 14:21 only fields contained in the table you select will be listed. Used with permission from Microsoft. Lookup wizard asks what sort order do you want for the items in your list box. Drop-down field panes display make, model, and year with buttons at the right labeled ascending. Figure 14:22 sort the information using a logical field such as the specific car details. Used with permission from Microsoft. Lookup wizard asks, how wide would you like the columns in your lookup field? Button is checked for hide key column recommended. Columns visible below for VIN, make, model, and V year. Figure 14.23. Recall the primary key is the field that ties the tables together, used with permission from Microsoft. Vehicleid is selected for what label would you like for your lookup field. Enable data integrity and restrict delete buttons are selected. Cascade delete also available. Allow multiple values button not checked. Figure 14.24. Enabling data integrity is a good idea if you are collaborating with others in the same database file. Used with permission from Microsoft. Now that you have created a relationship between the tables, build a query that joins the fields from the two tables together. To start, go to Query Design and bring in all the fields from both tables. In this example, the query will be saved as QRY New Vehicles, as it will be the driver for the new vehicle form to use in the vehicle fleet program. See Figure 14.25. A TBL vehicle and TBL maintenance queries displayed with table. B. Join Properties pane displays selected option. Include all records from TBL vehicle and only those records from TBL maintenance where the joined fields are equal. Figure 14.25a. In the query view, you can see the primary keys identified in each table. B. Define the relationship between the two tables and which records are created in the new table created from the form. Used with permission from Microsoft. Select QRY New Vehicle from the list of all access objects to create the form from New Vehicle. See Figure 14.26. Access will create the form automatically. This form allows the user to enter both the new vehicle that is part of the fleet and the initial check-in service performed on the vehicle. QRY New Vehicle file displays TBL vehicle. Vehicle ID and Maintenance ID fields both populated with new. Other blank fields include VIN, make, model, V-year, TBL maintenance, vehicle ID, description, repair date, and amount. Figure 14.26. Because relationships were created previously between the two tables using the wizard, when data is entered into the form, both tables are populated with the information. Used with permission from Microsoft. Using subforms. A subform is a form that is inserted in another form known as the main form. A form-subform combination may be referred to as a hierarchical form, a master detail form, or a parent-child form. Subforms are generally used whenever you want to display data from multiple tables where there is a one-to-many relationship. In a one-to-one relationship, each record in one table has no more than one related record in another table. This type of relationship is not common, as most information related in this way would be in one table, so there would be no need for a second table. By contrast, a one-to-many relationship is the most common type of relationship. In a one-to-many relationship, a record in one table can have many matching records in another table, and the opposite is true as well. For example, suppose you have two tables in your database, one called Employees and another called Employee Details. The Employees table contains basic information about each employee, such as their name, ID number, and job title. The Employee Details table contains additional details about each employee, such as their address, phone number, and emergency contact information. Because each employee has only one set of details, there is a one-to-one relationship between the Employees and Employee Details tables. To view and edit this information on the same form, you can use a subform. To do this, you could create a main form based on the Employees table, with fields for employee ID, first name, last name, and other relevant information. Then you could add a subform based on the Employee Details table, with fields for address, phone number, emergency contact, and other relevant information. By embedding the Employee Details subform within the employee's main form, you can easily view and edit data for both the employee and their details on the same screen. You can navigate between records in the Employees table and see the corresponding details in the subform, or you can add a new employee and their details at the same time. A many-to-many relationship means that for each record in one table, there can be many records in another table. Likewise, for each record in the second table, there can be many in the first. Many-to-many relationships cannot be directly represented in relational database programs. They have to be built by using two or more one-to-many relationships. For example, for any business, a many-to-many relationship exists between customers and products. Customers can purchase various products and various amounts of a product, and products can be purchased by many different customers. A third table is required to create the relationship between customers many and products many. Understanding how subforms and relationships work. Using subforms is an effective way to create one-to-many relationships and offers unlimited options for business use. In this type of association between two tables, the primary key value of each record in the primary table corresponds to the value in the matching field or fields of many records in the related table. For example, if you want to display an order with all of its details, you will use a subform. The order information would display on the main form one detail, and the order details would display on the subform many details. The data in the customer order table in Figure 14.27 is the one side of the relationship in this example. It creates a document number for the transaction, identifies the customer, provides room for notes, delivery instructions, special handling, etc., and date stamps the transaction. In contrast, the data in the order details table is the many side of the relationship, showing an unlimited list of items purchased in a transaction. Customer order form displays document, customer, dateout, and notes fields at the top, labeled one transaction main form, and item, rate, QTY, and amount columns at the bottom, labeled many items subform. Figure 14.27. The main form provides the lookup values to determine what to populate in the subform, which lists the items ordered. Used with permission from Microsoft. The main form and subform are linked so that the subform displays only records that are related to the current record in the main form. For example, when the main form displays a customer order by Arnold on 1/2022, as shown, the subform then displays items that were included on Arnold's to order only. If the form and subform were unlinked, the subform would display all the items that Arnold ever ordered, not just those ordered on 1/2022, on document 2. Adding a subform through the subform wizard. There are two common ways to add a subform to a main form. The quickest way is to simply open a form in Design View and then drag and drop a form from your list of completed forms that you want to be the many as your subform. However, using the form wizard can ensure that the correct relationships are established when creating the advanced form. The following example will walk you through the use of the form subform wizard to track your time away from the World Corp office on the golf course. Start by designing a query that helps ensure that relationships between the tables are created. To help you think through the query design, you might consider sketching it out on paper or in another app with boxes and arrows to show how fields are connected. Then you can take this plan and use it as your work through the queries when designing a form. Using the form subform wizard can also make designing the queries and the form easier. In this example, shown in Figure 14.28, you will design a golfing relational database that keeps track of individual scores and rounds. It may sound like a complicated task to create for a weekend activity, but with the wizard, it can take just a few minutes to have a great application in place for your out-of-office recreation. First, create 4 tables to help keep track of 1. The different courses TBL course ID, 2. The different players TBL player, 3. Each round played TBL round, and 4. The score shot on each hole played per round TBL score. Then, create a query that will bring together all 4 tables with all the fields from each table using the skills covered earlier in the chapter. The goal is to make TBL player the main form. With TBL round and TBL score listed as subforms, QRY round is selected from queries. Connected queries for TBL score, TBL round, TBL course ID, and TBL player are displayed. Table at bottom shows columns with TBL round, TBL score, TBL course ID, and TBL player. In field and table rows, Figure 14.28, 4 tables are joined in this query to create the main form and 2 subforms, used with permission from Microsoft. Now that you have created a query, save and close it. The next step, shown in Figure 14.29, is to select the Form Wizard from the Create tab in Access. A screenshot of Form Wizard highlighted in the Forms command group of the Create tab in Access. Figure 14.29. The query established the relationships between the tables and the Form Wizard found on the Create tab is used to create the form from the query. Used with permission from Microsoft. The following sequence of figures walks through the different options in the wizard. Once you have used the wizard a few times, you will find it easier to plan future forms and subforms for data management. See Figure 14. 30, Figure 14. 31, Figure 14. 32, and Figure 14. 33. Remember that we also use the form wizard in understanding and using databases. Form wizard asks, which fields do you want on your form? Query, QRY round selected in table queries. TBL round, rounded selected in available fields. Arrows are highlighted between available fields and selected fields panes. Figure 14. 30. The form wizard begins with determining the fields that will be used in the form and from which tables those fields come from. Used with permission from Microsoft. In Form Wizard, by TBL player is selected for how do you want to view your data. 2 categories of information are shown with options in each. Form with subform S button is selected. Figure 14. 31. Rather than creating a form with a subform, you can instead create 2 separate forms and link them together. Used with permission from Microsoft. Form Wizard asks, what layout would you like for each subform? Datasheet button is selected for both options. Tabular button also available for both options. Figure 14. 32. Each subform can be displayed differently on the main form. Used with permission from Microsoft. What titles do you want for your forms? Asked. Form player, subform round, and subform score and modify the form's design selected. Open the form to view or enter information is also available. Figure 14. 33. Choose modify to preview the form before using it to collect data. Used with permission from Microsoft. After you select finish in the wizard, the following form is created. Figure 14. 34. This database, built with 4 tables, 1 query, and 3 forms, will provide a way to keep track of weekend golf performance for years to come. Player is selected from forms. Categories for player ID, player name, round, and score are available. Round displays tabs for rounded, date played, and TBL round course ID, and score displays tabs for score ID, hole, score, and par. Figure 14. 34. This form was designed as a training aid to demonstrate how the form wizard can be used to create subforms. The subform to collect the scores is displayed in a tabular form. Used with permission from Microsoft. To review, the form wizard created 3 forms as shown in the All Access Objects section: player, round, and score. When you open the player form, it will display all 3 forms. In this example, Larry is the selected player on the main form, player ID 1. The subforms will display information related to only Larry. He is currently playing his first round at Twin Oaks on 5/24/22. We know this because the information displayed within the round subform is clearly highlighted in blue. Round is set to be a subform of player. Additionally, Larry has just entered his score on hole 3 of his first round. His score was a 3, and he also marked that the hole was listed as a par 3. Larry shot par. Score is a subform of round, so only scores for the selected round will be stored. As Larry continues his round, he can simply add additional rows of data from each hole he plays on the score subform. These scores will both be saved under round ID 1 and kept as Larry's unique scores. If Larry is playing against another player, you would navigate to the correct player on the main form and enter their round score as well. Larry can use this simple yet powerful form to keep track of unlimited rounds of golf. In the office, he might apply these steps to developing a way to keep track of a variety of business tasks or projects. For example, each of his employees could have an assigned project with numerous unique details concerning each project. The employee would be the main form, while the project names and project details could be the subforms. Adjusting a subform in Design View. Subforms are difficult to change and update within Design View of the main form that they are sitting on. A much easier way to alter a subform is to open that form separately, first making sure the main form has been closed. Using the previous golf example, if you want to add details to the round subform, for example, add a place for notes on weather or course conditions, it is best to open up the round form by itself and make the changes. Once the changes have been made, you can save and close the form, then reopen the main form, in this example, player, to see whether you need to adjust the size. After making any changes, always make sure the subform displays the new information within the main form. Learning objectives. By the end of this section, you will be able to use the tools to build a custom form, modify and add controls to a form, customize the appearance of a form by including images and modifying fonts. WorldCorp has manufacturing locations in the United States, China, and Germany, with headquarters in key metropolitan areas in those same countries. Smaller functional units are located in offices around the world, and there is an established international remote workforce. As you continue to develop an inventory database for potential retail locations its customers experience, forms will help users add data records to fields within tables. Those working in the new retail locations become the users of forms. As they receive shipments of inventory or create sales transactions for customers, their input is what truly creates the data. Above all, a form should be functional for them. Beyond functionality, a form that is customized in a way that makes it easier and faster to use will create a more enjoyable user experience. Consider our diverse workforce around the world. Knowing how to customize a form for cultural business practices is crucial in supporting the user. This will be no different as you develop and design an inventory database for a potential booming retail arm of WorldCorp. Typically, one of the first forms all users experience is the main menu at WorldCorp, which helps them navigate through all the other forms available to them in the database. Rather than scrolling through the entire list, the user can go to the main menu, a starting point for all navigation. Link to learning. A quick way to prioritize a main menu for any graphical user interface is to manage its settings. A main menu can be created either all at once quickly or over time, and the process can be creative and fun. Be sure to set the display form option to main menu so that when the database is first opened, the main menu form is opened up and ready for the user. This video on creating a menu GUI in Access 2013 discusses the basic steps in creating a main menu and, most important, walks through the display options. Building a custom form. In general, using the form wizard will be the quickest and most efficient way to create a custom form. We covered how to do that in Understanding and Using Databases. Here, however, we will walk through the steps of building a form from scratch in Design View to demonstrate all of the possibilities. Start by selecting the Query Design option under the Create tab in Access, and you will create a blank form in which you can start working. Figure 14:35 shows the details section that appears when you create a blank form. A blank, gridded form labeled Form 1 is visible with black dots in the background. Rulers show at the top and left side. Figure 14:35 from the Create tab, choose Form Design to create the form from scratch. Used with permission from Microsoft. The next step is to save the form FRM main menu and start planning how you want the main menu to look and operate. Form views and tools. Right-click on the top of the form to see the list of options as Figure 14:36 shows. Here we will review the 4 ways to view a form: Form View, Layout View, Design View, and Datasheet View. The open pane displays options for Save, Close, Close All, Form View, Layout View, Design View, and Datasheet View. The last 4 views are highlighted. Figure 14:36 to begin a new form, you must first save it. Used with permission from Microsoft. Form View. Form View shows us what the form will look like for the user. Data can be changed in Form View, but formatting cannot be changed. Whenever a form is launched, it will first be displayed in Form View. It is recommended to continually check the form view while creating a form to make sure that the final version of the form displays all of the desired options. Layout View. Layout View is a feature that allows us to design and customize the layout of forms and reports visually by dragging and dropping fields and other objects onto the design surface. It is helpful for inexperienced users because it provides a more intuitive and user-friendly way to create forms and reports than the traditional design view. In Layout View, you can see how your form or report will look as you design it, and you can easily move fields and other objects around to create the desired layout. For example, let's say you want to create a form to enter data about damaged items that need to be removed from inventory. In Layout View, you can drag and drop fields such as item name, UPC code, quantity, description of damage, and date onto the form, and then arrange them in a way that makes sense for your users. You can also add other objects such as labels, images, and buttons to make the form more user-friendly. Overall, Layout View is a helpful tool for creating forms and reports in Access, particularly for the least experienced users who may not be familiar with the intricacies of Design View. Design View. Design View is a feature that allows us to create and modify the structure of tables, queries, forms, and reports in a more detailed and precise way. Similar to Layout View, in Design View for forms and reports, you can add and arrange fields, labels, buttons, and other objects, and set their properties to control their behavior and appearance. However, Design View provides a more granular level of control over the structure and properties of your database objects, allowing you to create more complex and customized solutions. It also allows you to view and modify the underlying SQL code that Access generates for your objects, which can be helpful for troubleshooting and advanced customization. Design View is a powerful tool for creating and customizing the structure and functionality of tables, queries, forms, and reports in Access, and is helpful for naive users who want to create more complex and customized solutions. Datasheet View. Datasheet View is similar to what you might see in a spreadsheet program. The data is in a table grid like Excel. This allows you to interact with the information in a form similar to how you would work in Excel. You can add or delete records, rows, and add or delete fields, columns easily in this view. You can also use some of the common keyboard shortcuts for copy and paste. Having this view option can depend on which version of Access you are using. As of 2021, Datasheet View was removed from Forms in Access. So if you are using a new version of the app, you will likely not have the Datasheet View option. Using the Form tool. A list of form tools is available within the Form Design tab on the right side of the ribbon. To add existing fields to a form, click the Add Existing Fields command, see Figure 14.37. The field list pane will appear and you can select a field or fields to add to your form. Screenshot of Tools command group displays these options for selection. Add existing fields, property sheet, tab order, chart settings, subform in new window, view code, and convert forms macros to Visual Basic. Figure 14.37. You can begin to add elements to your form such as fields using the Tools command group, used with permission from Microsoft. An option set in Design View on the property sheet is called a form property. These options control how the form looks, works, and interacts with the rest of the database. Use the tabs to find the specific property you want to set, and use the help available to you in the bottom left corner of the Access window to learn the function of each property setting. In many cases, the default setting may be adequate for getting started. You can use tab order to help control which section of the form the cursor moves to next. This feature provides ease of use for gathering data in a user-friendly way. When adjusting tab order, always consider the layout of the form. What is the first thing the user will do, what is next, and so on? Also consider omitting any fields the user will simply tab through, for example, autonumber fields. These types of fields can be omitted altogether for a better user interface experience. Using the Split Form tool. After building a table, you can create a split form. Select the table from the All Access Objects list and then go to the Create tab. Under More Forms, select Split Form. In this example, Figure 14.38, you can collect a list of your favorite jokes. The split form shows the datasheet, a running list of jokes in the lower section, outlined in yellow, while allowing access to the single form information outlined at the top. Screenshot of a split form titled TBL Jokes. Top portion displays categories for joke ID, joke, reply, origin date, and notes with fields populated with information. Bottom table displays same information in column form. Figure 14.38 split form view allows you to the information as it would look in the form as well as the tabular view showing each record in the table. Used with permission from Microsoft. Using a split form may be helpful when you are scrolling through a datasheet to make changes, because it enables you to highlight a row of data in the single form view. As you have seen, a common theme in form design is making the process easy and intuitive for the user. Adding controls to a form. The form control is the part of a form that is used to enter, edit, or display data. Remember that controls can be bound, unbound, or calculated. In understanding and using databases, we covered how to use the control wizard to walk you through adding controls to your form. Here, we will go into more detail about the different types of controls you can add and how to add them without the wizard. As an example of adding controls, start by creating a main menu for a multi-user-friendly database, using the example of a carpeting business, as Figure 14. 39 shows. A file titled FRM Main Menu displays main menu across the top in large font with a button at the left labeled Carpet Calculator. The background is spiral designs in gray and white. Figure 14. 39 controls are used to customize the form by inserting images, text boxes for titles, and other related elements. Used with permission from Microsoft. When helping a customer, an agent of the business would begin by opening the main menu form. Notice that a form control, Carpet Calculator, has been added to the main menu as the first control. To respond to a customer's call, the agent will most likely need a form to calculate a potential quote for a project. The form control that was added is a button, one of many options available in the Controls section of Form Design. Common controls. Controls can be placed on forms to add to their functionality. This section walks you through the procedure for adding several common controls. The command control is used to start an action or a set of actions. For example, the button in Figure 14. 39 is designed to open the Carpet Calculator form. The command button wizard shown in Figure 14. 40 appears automatically when you add a button to a form in Design View. When you select Form Operations within the Categories field, followed by Open Form within the Actions list, the wizard records a macro or event procedure and attaches it to the command button's on-click property. Command button wizard asks, what actions do you want to happen when the button is pressed? Form Operations is selected from Categories and Open Form is selected from Actions. Figure 14. 40 You can further customize the form by adding a command button to perform a specific task such as closing or printing the form. Used with permission from Microsoft. Text boxes. Text boxes are great items to elevate the use and function of any form. They can be bound to a field or unbound. You can use an unbound text box to display the results of a calculation or to accept input that you don't want to store directly in a table, such as the current date and time, information that is not connected to a field in a table or query. It is easiest to add an unbound text box in Design View. On the Design tab in the Controls group, click Text Box. Position the pointer where you want the text box to be placed on the form or report, and then click to insert the text box, outlined in yellow in Figure 14. 41. In this example, the expression equals now was added to the unbound text box within the properties sheet circled. Note that Access also places a label to the left of the text box. In this example, the label was deleted, as the current date and time do not require a label. Design View displays boxes for text insertion on main menu. Property Sheet Table displays data information, default value is equals now. Form View displays clean information on main menu window. Figure 14. 41 Elements such as the date and time can be added to text boxes when inserted into the form. Used with permission from Microsoft. Combo boxes. A combo box is an object or control that you can also place on a form. It displays a list of values from which a user can quickly select. The values displayed within a combo box can be populated by a table query, value list, or field list. Combo boxes are commonly used in forms to provide users with a list of choices to select from, while also allowing them to enter a new value if none of the predefined options meet their needs. Combo boxes are helpful for numerous reasons. As an example, they can simplify data entry by providing users with a list of predefined options to choose from, which can help reduce errors and ensure data consistency. In addition, combo boxes can be set up to validate the data entered by users, such as by checking if the input matches a specific format or if it exists in a related table. This helps ensure the data entered into the database is accurate and complete. In consideration of your users in retail, combo boxes can increase efficiency by allowing retail associates to quickly select from a list of options, rather than having to manually enter the information every time they handle any of the inventory. In the example shown in Figure 14.42, a new customer form is designed with two combo boxes, one for state and the other for city. These two combo boxes were designed differently. The state combo box was built from a table of state names and abbreviations, while the city combo box was built from a query of city and state names. The query is set to display only the conditions selected by the state combo box. A customer's window lists options for selection, state abbreviation, and state name in the state dropdown. B, a customer's window lists options for selection in the city dropdown. Figure 14.42 drop-down menus can be helpful to reduce the amount of information the user needs to type manually into the form. These menus can be formatted and built in different ways, as evidenced by the state combo box in A and the city combo box in B. Used with permission from Microsoft. An additional option that can be added to any combo box is the ability to update the list provided in the combo box. In the example, only a couple of states and cities are listed, so you may want to include a shortcut for adding a new state or city to the table. Combo boxes maintain spelling integrity. In this example, see Figure 14.43. FRM state circled is a form designed to update the TBL state table. This form was then added to the List Items Edit Form criteria on the associated property. Users can select List Items Edit Form option, located in the Properties sheet, which launches the FRM state form to update the table. A new customer form displays stated highlighted in state option. Property sheet highlights FRM state in List Items Edit Form. B, customers pane lists options for selecting state name in state dropdown. Figure 14.43. A table in the database A can be used to populate the options in the combo box so that if edited, B, the form is automatically updated as well. Used with permission from Microsoft. Changing the appearance of a form. This section discusses changes that make a form easier to use and more appealing overall, and that will allow for personalization of the project, including company branding. Before you start to manipulate the appearance of a form, consider creating a template for both primary default views, single form view, and continuous form view. It is important to have a starting point to build from if you anticipate creating numerous forms for the project, all of which will require formatting changes. In this section, you will learn how to add headers and footers, add a title, modify text, control colors, and finally, add logos and custom imagery. This will be the starting point for you to explore your creativity, adding and modifying headers and footers. Adding header and footer sections to a form in Access takes just a few simple steps. Start by displaying the form in Design View, see Figure 14.44. Right-click on the grid area on the design surface and select Form Header Footer from the shortcut menu. Pane open in Form 1 lists options for selection. Build Event, Tab Order, Paste, Fill Back Color, Alternate Fill Back Color, Ruler, Grid, Page Header Footer, Form Header Footer selected, Form Properties and Properties. Figure 14.44. You can include company information or logos to each page of the form by adding a header. Used with permission from Microsoft. Adding a title to the form. A clear and descriptive title can help users quickly identify the purpose of the form and understand how it relates to the overall database. This may be the very first thing they see when the form opens. A well-crafted title can communicate important information about the form, such as the type of data it contains, the purpose of the form, or the specific function it serves within the database. This can help users understand how the form fits into the larger context of the database and improve their overall understanding of the system. In addition, consistent use of titles can help maintain a cohesive and organized database structure, making it easier for users to locate specific forms and navigate the database overall. In consideration that you're a WorldCorp employee, adding a title to a form can add a level of professionalism to the database and make it look more polished and organized. This can improve the overall perception of the database. Often, the original form design is built around the title. When you envision a WorldCorp user interacting with a form you designed, consider the title placement, size, and font selections in correlation with the company branding. As shown in Figure 14.45, you can add a title from Design View on the Form Design Tools tab in the Header Footer command group. Select Titles circled to add a text box to the header section of the form, Figure 14. 46. Screenshot of title being selected from Header Footer Command Group in Form Design tab in Access. Figure 14. 45. Including the date and time in the header could be helpful, especially when sorting or tracking information from completed forms. Used with permission from Microsoft. The form header section of Form 1 is populated with main menu in text box. Figure 14. 46. The title of the form should be descriptive of the data you will collect in the form. Used with permission from Microsoft. Adding and formatting text. In today's modern world with information at our fingertips, marketing toolkits, MTs, are often available and are expected to be used when available. Numerous company websites now have highly detailed information on their branding. As an example, Tennessee Tech is one of many institutes that make branding information available to both employees, faculty and staff, and customers, students. This enables their current workforce and stakeholders to post on social media, post flyers, or add branding information to newsletters as a way of promoting the company culture. MTs provide users with the various elements the company requires, all promotion, training, and public relation materials. From the color scheme to the font to the logo placement, expectations in design are being elevated every year. In the current example, make sure to select the text box that you want to format. If you want to apply the same formatting to multiple text boxes, click and hold Ctrl on the keyboard to select multiple text boxes before you apply the desired formatting. See Figure 14. 47. Font and control formatting options are highlighted on Format tab. A box reads, both the font and shape options were changed. Font, Broadway font size, 18, shape fill, transparent, shape outline, transparent. Figure 14. 47. The tools to customize the header are similar to the text formatting tools in other Microsoft apps. Used with permission from Microsoft. When you are working in Design View, remember to return to Form View to preview your results. You may need to repeat this several times to achieve your desired formatting. Adding logos and images. Logos and images are important elements to add to forms for several reasons. They can be used to reinforce the WorldCorp branding and create a consistent visual identity across all aspects of our databases, including forms. They can enhance the visual appeal of a form, leading to a more engaging and attractive experience for the user. They can also be helpful in communicating information to users, for example, highlighting important points, guiding users through a process, or providing visual cues for navigation. Consider the rapid rise of self-ordering screens at your local fast food restaurant. Images help a diverse group of users identify what they would like to order from the menu. In addition, logos and images can evoke emotional responses in users, creating a more positive overall experience. For example, using images of happy customers can help create a more positive association with the database and improve user satisfaction while helping a customer in a retail location. Adding logos and images can improve the overall user experience and encourage users to use the database more frequently. To insert a logo from Design View, select the text box that was created when inserting the title. Then select Logo Figure 14. 48. The Windows folder will open, allowing you to select a picture file to be inserted as a logo. Figure 14. 49. Logo is highlighted in the Header Footer Command Group on the Form Design tab. An image of a shark is inserted to the left of the main menu text box in Form Header. Figure 14. 48. Insert your company logo in the header to customize the form. Used with permission from Microsoft. A screenshot of the main menu for Form 1 is visible. Main menu is in large font at the top with a shark icon to its left. Figure 14. 49. After you have added elements such as the company logo, you can preview what users will see using the Form view from Form Design tab. Used with permission from Microsoft. Formatting a form can be an enjoyable and creative process. It is satisfying to invest the time needed to craft the most visually pleasing form. Once you are satisfied with a design, consider creating a template of it that you can copy and paste as a starting point for additional forms. That way, you can avoid duplicating the effort that you have put into perfecting your form design. Learning objectives. By the end of this section, you will be able to create a customized report. Modify what appears on a report. Change the appearance of a report. Reports offer a way to view, format, and summarize the information in your Access database. For example, at WorldCorp, you can create an invoice for all your sales or a summary of total sales across different regions and time periods, depending on which corporate business unit on WorldCorp you are surveying. In the chapter on understanding and using databases, you learned about how to create and modify reports using the Report Wizard. In this chapter, we will go deeper into creating and modifying reports. Building a custom report. The Report Wizard does provide a quick and efficient way to create reports. At times, however, you will need to make a report from scratch. Understanding the section types enables you to use them to their fullest potential. Often, queries are used to combine tables and define fields that will be included in a report at WorldCorp. As with creating a form, queries become the primary building block for developing a desired report that meets the current demands of the ever-changing WorldCorp objectives. A report is divided into sections that can be seen in Design View. To create professional-looking reports, you will need to understand how each section works. For example, the section in which you choose to place a calculated control determines how Access calculates the results. What you want on the cover page of the report may be very different than what you want at the top of the pages that follow. In addition to the report header, report footer, and page footer, which we covered in understanding and using databases, there are other sections in the report that you should know. Group header. This section appears at the beginning of each group in the report and is used to display summary information about each group. Detail. This section is where the actual data from the report is displayed. It appears for each record in the report. Group footer. This section appears at the end of each group and is used to display summary information about the group. Using these sections allows you to create a well-organized, easy-to-read report that contains all the necessary information. Modifying a report. There are several tools and views that you can use to create, format, and customize reports. The different views allow you to see and preview your report in different ways, each of which may be useful to you at times. We reviewed these different views and some of these tools in understanding and using databases, but here we will go into more depth. Layout view. Layout view is a great way to see the print preview grid lines, with the ability to change the size and placement of all labels, text boxes, and design elements. Right-clicking and selecting Layout View shows how much of the report will fit on a page. In Layout View, each control on the report displays real data, making this a useful view for setting the size of controls or performing tasks that affect the report's appearance and usability, as Figure 14. 50 shows. Screenshot of an invoice for Awesome Clothes Inc. displays an open pane with Save, Close, Close All, Report View, Layout View selected, Design View, and Print Preview available for selection. Figure 14. 50 in the Layout View, you can make changes while viewing the form to see how the user will see the form with data included. Used with permission from Microsoft. Design View. In Access, Design View is a view that allows you to create and customize the layout and structure of a report. Design View is an important feature for creating professional-looking reports, as it allows you to customize the design and appearance of the report to suit your needs. When you open a report in Design View, you'll see a grid that represents the layout of the report. The report is divided into several sections, including the report header, group header, detail, group footer, page footer, and report footer. Each section has its own set of properties that you can modify to change the appearance and behavior of the section. You can also add various types of controls to the report, including text boxes, labels, buttons, and images in this view. Grouping and sorting options to the report can help organize and display the data in a meaningful way. Design View also allows you to set properties for the entire report, such as its orientation, margins, and page size. You can also add themes and styles to give the report a consistent and professional appearance. Overall, this view allows you to create custom reports that suit your needs in inventory management and retail store operations while at WorldCorp. By taking advantage of the many customization options available in Design View, you can create reports that are both informative and visually appealing. As you can see in Figure 14. 51, the Design View includes all sections of the report. Screenshot of invoice for Awesome Clothes Inc. Displays grid lines and text boxes and sections for report header, detail, page footer, and report footer in design view. Figure 14.51. The grid lines in design view are helpful to keep the form looking professional by lining up controls and sizing elements appropriately for the fields. Used with permission from Microsoft. Grouping and sorting in a report. Tools that can group and sort your information will be of utmost importance when organizing your report. Information is often easier to understand when it is divided into groups. For example, in the invoice for Awesome Clothes Inc., the sections are used to group the details and relevant information. In addition, placing a total, a sum of all amounts, in the report footer section can replace a lot of manual interaction with a calculator. The customer can quickly see the total of the grouped sections, showing the amount owed. Grouping and sorting are important features in Access reports that allow you to organize data in a meaningful way. Additional considerations why you might want to use grouping and sorting in your Access reports are endless. Grouping and sorting can make it easier for users to read and understand the data in a report. By grouping related data together and sorting it in a logical order, you can help users quickly identify patterns and trends. It also allows you to summarize data by creating subtotals or totals for each group. Sorting can help you identify outliers or anomalies in your data. For example, if you're sorting a list of customers by purchase amount, you might notice that one customer has made an unusually large purchase, which could indicate a potential sales opportunity or a data entry error. Grouping and sorting can help you make more informed decisions by presenting the data in a clear way. By using these tools in different ways, you can analyze the data from multiple perspectives and identify opportunities for improvement. By using these features, you can create reports that are more informative and easier to understand, which can ultimately help you make better business decisions that affect our success at WorldCorp. Filtering records. Another useful tool in Access is the filtering tool. This gives you the ability to filter a report prior to printing or presenting the information. There are just a couple quick steps you can take every time to ensure the information that is obtained in the report is correctly filtered to the desired data points. To start, open the report in Design View. Click on the Sorting and Grouping button in the Grouping and Totals section of the Design tab on the ribbon. In the Sorting and Grouping dialog box, select the field that you want to filter by. Simply click on the button next to the filter property. In the Filter dialog box, select the criteria that you want to use for the filter. You can select from a variety of options, including equals, not equals, contains, does not contain, between, and more. Enter the value or values that you want to use for the filter. You can enter a single value, multiple values separated by commas, or a range of values. Next, click the OK button to close the Filter dialog box and save and close the report. Open the report in Print Preview or Report View to see the filtered results. Note that you can also apply filters to a report while viewing the report in Print Preview or Report View. To do this, click on the Filter button in the Sort and Filter section of the Home tab on the ribbon, and then select the criteria that you want to use for the filter. To use an actual example, let's filter our customers living in Ohio. Simply right-click on states listed as OH and click Text Filters equals OH, see Figure 14.52. A screenshot of RPT Customer Report Form displays information in rows and columns: name, address, city, state. Information in the state column is selected. An open pane shows text filers selected from options listed. Figure 14.52. A report of information gathered from data entered into the form can be sorted and filtered by text or by fields. Used with permission from Microsoft. In Figure 14.53, Access applies the filter, and you can now print the report including only the data selected from the filter. A table is displayed with columns labeled name, address, city, state, and zip. Information fills the rows below. Figure 14.53. The report will only display the information based on the filter. The remaining information will be hidden but is still contained in the table. Used with permission from Microsoft. Adding totals and subtotals. Adding totals and subtotals to a report in Microsoft Access is useful for summarizing data and providing meaningful insights to numerous activities at WorldCorp. A few reasons why you might want to add totals and subtotals to your report could include summarizing data, grouping data, identifying outliers, and comparing datasets. Totals and subtotals allow you to summarize data in a report by providing aggregate values such as sum, average, count, minimum, maximum, and more. This can help users quickly understand the overall trends in the data. Grouping data by a particular field or criteria, such as by department or product category, is very useful for subtotals by allowing users to analyze the data from different perspectives. Totals can be used to identify outliers or anomalies in the data. For example, if the total sales for a particular product are much higher than the other products, it may indicate that there is a potential opportunity for growth. In addition, they can be used to compare data across different time periods, geographic locations, or other criteria. This can help users identify trends and patterns in the data that may not be immediately apparent. Layout view be used to add totals or averages to a report. To add a total in a report, start by opening the report in Design View. Click on the field where you want to add the total. Then in the Properties window, scroll down to the Total property and select the type of total you want to add. See Figure 14.54 for the available options. Finally, save the report and reopen it in Print Preview or Report View to see the total. A table with numbers is visible in the background. An open pane displays total amount selected and opens to sum selected, average, count records, count values, max, min, and standard deviation. Figure 14.54 Access provides some tools to help you analyze information, although not to the extent that you can do data analysis in Excel. Used with permission from Microsoft. Adding fields to report. To add fields to a report in Access, start by opening the report in Design View. Select the Add Existing Fields button in the Controls section of the Design tab on the ribbon. In the Add Existing Fields dialog box, select the table or query that contains the fields that you want to add to the report. Select the fields that you want to add to the report by checking the boxes next to their names. Click the Add button to add the selected fields to the report. In addition, you can drag the fields to the desired location on the report once they are added. You can also resize the fields by dragging the edges of the control box. Make sure to save the report. Once you are done adding the fields to the report, you can customize their appearance and formatting by adjusting the properties in the Properties window. As an example, we will review how text boxes can be added to a report to improve its ability to communicate information at WorldCorp. Start by opening your report in Layout View or Design View. Note: if your database does not contain any tables, the field list pane will be empty. When you find the field S you want to add, double-click the field and then drag it from the field list pane to the form or report, as Figure 14.55 shows. Add Existing Fields is selected from the Tools command group. Field list pane displays fields available for this view: customer ID, address, city, state, zip, document, dateout, notes, customer order detailed, item, rate, QTY, amount, and first last. Figure 14.55 From the Report Layout Design tab, you can add additional fields to the report from the Tools command group. Used with permission from Microsoft. Adding time and date. One area that is very important on an invoice is the invoice date and due date. In addition to the original purchase date, it can be helpful to calculate a due date or add a mailing date. In the following example, we will see the procedure for adding 3 dates: origin date, due date, and mailing date. This custom build will clearly explain to the customer the payment due date parameters. Start in Layout View or Design View. The dateout field, as shown in Figure 14.56, was included in the field list. This information can be presented on the report and used later in calculating the additional information. Dateout is selected from the field list pane. A dateout text box is visible in the document along with other text boxes. Invoice hash, document, and another dateout box. Figure 14.56 Choose the field you want added to the report and place in the report in the desired location. Used with permission from Microsoft. Formatting a text box prior to copying it is highly recommended to save time and keep attributes alike. In the example shown in Figure 14.58, 57. Copy and paste the label and text box twice, pasting the second instance directly below the first. Then, change the labels to represent the 3 dates the customer should see. Purchase date, invoice date, and due date, figure 14. 58. For appearance, the borders on each label were changed to transparent. A screenshot of 3 date-out text boxes being pasted into a document, one right under the other. Arrows point from the first one to the second and third ones. Figure 14. 57. If you are using a similar layout for multiple fields in the report, you can insert once and copy and paste for the additional fields. Used with permission from Microsoft. Labels for 3 text boxes are purchase date, invoice date, and due date. Dates fill the text boxes to the right of the labels. Figure 14. 58. Descriptive titles are needed for each field in the report. Used with permission from Microsoft. Next, open the property sheet and select the invoice date text box. Change the control source to equals date, a quick change that will provide the current date for the text box, as shown in figure 14. 59. Invoice date in an invoice is formatted to be entered as 6/5/2022. The property sheet displays control source in the data tab as equals date. Figure 14. 59. By changing the properties for the inserted field, you can add formulas to automatically populate certain aspects of the form. Used with permission from Microsoft. Select the due date text box and open the property sheet. Change the control source to equals date out plus 30. The control source is the field to which your text box is linked. It will display the data in that field and any updates you make to the field. This sample expression makes a calculation. It takes the field dateout and adds 30 days to the field. The text box will display the expected due date of the invoice, as you can see in figure 14. 60. As this is probably the most important date in the report for the customer, change the font to red and make it boldface. This subtle change will help direct the customer's eyes to the important due date field. Due date in an invoice displays as 7/1/2022. The property sheet displays control source in the data tab as equals date out plus 30. Figure 14. 60. Mathematical operators can be utilized in field properties to modify dates as needed. Used with permission from Microsoft. Changing the appearance of a report. In understanding and using databases, we briefly covered how to add images and custom text to your report. Here we will go into detail about further customizing the appearance of your report, adding and formatting text. Many companies require particular directions when they invoice their customers. Terms and conditions are required and standardized through contracts. Placement, size, and accessibility are important, especially for current or future customers. In the example of the customer invoice, suppose you want to include a direction in the page footer section to instruct the customer on how to make a payment. In the following example, a label is used in the report footer section as direction for making payment. It provides information on how to direct the payment and where to send it. In designing this label, you will need to know how to set the size, font, and color to meet company guidelines or standards. To do this, open the report in Layout view and select the label option from the Report Layout Design Controls, see Figure 14. 61. Draw the label in the footer section and proceed to enter the payment directions. Screenshot of Report Layout Design tab in Access with icons displayed. Select text box label highlighted, button tab control link combo box list box checkbox attachment and image. Figure 14. 61. The tools available to customize a report look very similar to those used to customize a form. Used with permission from Microsoft. While still on the label, select the label option format and adjust the font, size, and color within the font section. Within the label, font styles, sizes, and colors can be changed from the ribbon, as in all Microsoft Office products, Figure 14. 62. The font command group is selected from the Format tab. The report displays Snap ITC font in size 14 in a blue color for the text visible. Figure 14. 62. Text contained on a form can be adjusted by size, font type, and others similar to changing fonts in Word. Used with permission from Microsoft. Once complete, review the report in Print Preview view. Make sure the message is displayed in the correct position and with the correct formatting. You can repeat these steps for any other information that may be standardized on the report, e.g., contract guidelines or customer service contact information. Adding page numbers. Open the report in Design View or Layout View. On the Design tab in the Header-Footer group, click Page Numbers. When the Page Numbers dialog box appears, choose the format, position, and alignment that you want, Figure 14. 63. Note: if you do not want a number to appear on the first page of the report, be sure to uncheck the option to clear the Show Number on the first page checkbox. When you are done, click OK and the page numbers will be added to the report. To see how the page numbers will look when the report is run, switch to Print Preview. If page numbers is selected, displays format page N of M, position bottom of page footer, and show number on first page checked. B page 1 of 1 shows on bottom left, Figure 14. 63. A. In the header-footer command group, page numbers can be added to multi-page reports. B. Just as in Word, you can determine the formatting and location of the page number on the report. Used with permission from Microsoft. Adding logos and images. In the example of the customer invoice, a company logo helps clearly represent the company's ownership and brand. Beyond simply using font styles and colors to distinguish your company, a company logo can make reports look professional. Note: before finalizing a report that may go out to a large audience, be sure to check with your company's guidelines on placement, size, and color guidelines for logos. Larger companies often offer a marketing toolkit to help guide employees in the use of logos. To better understand the use of logos, we will walk through steps for adding and modifying a static image on a form, using our clothing company example. First, choose the image that you want to use as the logo for the clothing company. Ideally, this image has been given to you or made available. Company logos are usually saved as a JPEG or PNG file type. Open the report in Design View when you are ready to add the logo. Select the Image button in the Controls section of the Design tab on the ribbon. This will add an image control to the report. Resize the image control to the desired size by dragging the edges of the control box. Right-click on the image control and select Properties from the context menu. In the Properties window, go to the Picture property and click on the ellipsis button to select the image file that is the saved logo. In the Picture Size Mode property, choose the Clip option to ensure that the image is displayed at its original size. Save the report once complete. You can also modify the appearance of the image by adjusting the properties in the Properties window. For example, you can change the border style, color, and thickness, as well as the background color of the control box. In this example, shown in Figure 14, 64, the logo was placed in the center of the invoice header section, replacing the company name. Logo is selected in Header-Footer command group on Report Layout Design tab. A rainbow-colored, swirly logo with Awesome Clothes Inc. in blue font is inserted in the middle of an invoice. Figure 14. 64 company logos are an important part of reports such as invoices sent customers and are easily added in the header. Used with permission from Microsoft. Now it is time to print your report. Before you do, make sure you are happy with the final version. Remember that although forms are designed for users, reports are for audiences and stakeholders. It's important to consider whether your message and data are clearly presented and whether the report meets all company guidelines for publication. Spotlight on ethics. Privacy in 2 acts, FERPA and HIPPA. Personal information such as addresses, work history, and in some cases medical history, could be contained in a variety of different databases and with a variety of different organizations or companies. Our personal information is regularly exchanged and sold to entities to solicit sales, send mailers, or for political purposes, just to name a few examples. More and more people are becoming concerned with the use and privacy of their information. 2 areas of particular concern are medical data and academic educational data. You might be familiar with FERPA, the Family Educational Rights and Privacy Act of 1974. This piece of legislation was passed to protect your academic records. The act also gives protections to individuals for how their educational records are used by government agencies such as the Department of Education. Your right to keep those records private is part of the legislation. In addition, you have the right to request your records at any time. The data essentially belongs to you. There are certain provisions that allow usage of the data for reporting and auditing purposes. But when the data is used, personally identifiable information is generally not disclosed. In a similar manner, HIPPA, or the Health Insurance Portability and Accountability Act of 1995, protects your medical information. Your specific medical information is kept private under most circumstances. Information such as treatment plans or medication might be shared with insurance companies, but that information is protected through the insurance companies from outside entities under the same HIPPA legislation. In general, under both legislative acts, unless there is a justifiable compelling reason to disclose your personal information, it is kept private. Both acts give options for you to disclose to certain entities. For example, you can decide to allow your parents access to your educational records or your spouse partner have access to your medical records. Signed approval for such disclosure is needed to release the information to someone other than yourself. Learning objectives. By the end of this section, you will be able to record a macro that automates a common task, record a macro that enhances database functions, demonstrate some understanding of macro code. A macro is a set of instructions that can automate repetitive tasks or perform complex operations with a single click. Macros can be created using the Macro Builder, which provides a graphical interface for creating and editing macros. Examples of how a macro can be used in Microsoft Access are many. As an example, your database under construction that tracks inventory for retail stores that WorldCorp would like to launch has numerous options to consider. Each time a new transaction is entered, you need to generate an invoice for the customer that includes their name, the date of the sale, and a list of the items bought. To automate this process, you can create a macro that performs the following tasks. Open the orders table and find the most recent order. Get the customer's name from the customer's table. Get the date of the order. Get a list of the items ordered from the order details table. Create a new record in the invoices table. Populate the new record with the customer's name, the date of the order, and the list of items ordered. Save the new invoice record. Once you have created this macro, you can run it whenever you need to generate a new receipt. Access will automatically perform all the necessary steps, saving you time and reducing the risk of errors. Macros provide the ability to automate repetitive tasks, improve productivity, and reduce errors in database management. Creating and recording macros. Macros can make tasks that you routinely perform in Access quicker through automation. Macros are built using computer coding language to perform specific tasks such as running reports, printing forms, or copying data from one table into another table. To begin using macros, open the Macro Design Builder located under the Create tab. This will create a blank macro builder, which can be saved and stored for later use in the All Access Objects area. The Macro Designer on the right side, figure 14.65, contains the action catalog where all of your actions will be stored in folders. You have data entry options, data import-export, and so on, and on the left in the main area you have a blank canvas to start building your macro. Action catalog is selected. Macro from macros and code group inserts add new action pane on a blank page. Action catalog lists options in program flow actions and in this database categories. Figure 14. 65 macros are computer code written within the program to tell the app an action or actions to perform. Used with permission from Microsoft. Recording a macro to automate common tasks. Recording a macro to automate tasks in Access is a common way to save time and increase productivity. When you record a macro in Access, you essentially create a set of instructions that Access can use to automatically perform a sequence of tasks. Let's say you frequently need to create a report that shows the total sales for each region of the country in the growing area of retail sales. You can use the macro recorder to automate this process. First, select the Create tab in the ribbon and select Macro. In the Macro Builder, click the Record button to start recording the macro. Perform the actions you want the macro to automate. For example, you could select the fields you want to include in the report, specify the criteria for grouping the data by region, and apply formatting to the report. When you have finished performing the actions, click the Stop Recording button in the macro builder. Give the macro a descriptive name and save it. Now, whenever you need to create a report that shows the total sales for each retail store, you can simply run the macro you recorded, figure 14. 66. Access will automatically perform all the steps you recorded, saving you time and reducing the risk of errors. All Access objects window lists categories, tables, queries, forms, reports, and macros, with MacNewCustomer listed below and selected. A pane opens with Run and Design Review options. Figure 14. 66. Recording a macro is an easy way to automate a task such as running a report or printing a form that you perform regularly. Used with permission from Microsoft. A common use of macros is to add a button to a form. In the previous section, we discussed how a main menu form can help improve user experience by creating a navigation map. Buttons can have macros embedded that open and close certain forms. They can also control what record source is displayed. For example, suppose you want to add your customer form to the main menu. The original goal is to add a button that will open the customer form. However, if you want to add a button that will add a new customer, you can create a macro that will open the customer form and move the record to the new source. The open form is shown in figure 14. 67. Macro 1 file visible. OpenForm category lists fields for form name, view, filter name where condition equals, data mode, and window mode. Add new action button at bottom and hyperlinked update parameters option available. Figure 14. 67 macros can be added to forms through buttons and can be programmed to perform a wide variety of actions such as adding a new field. Used with permission from Microsoft. You will see the form name with a drop-down arrow which will show you the forms available in your database. For each form, there is a View option, which will allow you to open the form in Form View, Design View, or Print Preview View. You also can apply a filter name or a condition. In Figure 14. 68. The MacNewCustomer macro that was created centered on finding particular records. You will notice this option is available to modify. OpenForm category fields listed, form name, view, filter name where condition, data mode, and window mode. GoToRecord category fields listed, object type, object name, record, and offset. Add new action available below. Figure 14. 68. The drop-down menus give you options such as adding or deleting records in the form, used with permission from Microsoft. Recording a macro to enhance database functions. By customizing your database with macros, you can create a system for accomplishing many similar operations easily and efficiently. Two common applications for macros are displaying message boxes and validating data. Displaying a message box. You can use the MSG box action to display alerts, warnings, and other useful information. The MSG box action has 4 arguments: message, beep, type, and title. Data validation, often used in Microsoft Excel, data validation is an extremely helpful step to take prior to adding the data to the database. To ensure that only valid data is entered in a form, you can specify a validation rule for the control in the form or set record and field validation rules in the underlying table design. For more complex data validation, you can use a macro or an event procedure to specify the rule. As another example, you can use the Run Application macro to run a Microsoft Windows-based application, such as Excel, Word, or PowerPoint, from within Microsoft 365. For example, you may want to paste Excel spreadsheet data into your Access database. This can greatly enhance your database's ability to work with imported data. Reviewing completed macros. One of the easiest ways to review a macro is to simply run the macro and see if the desired outcome occurs. At any point, a macro can be edited to better serve the database developer's goal for how it will function. To review completed macros in Access that have been developed, you can start by opening the database that contains the macros you want to review. Go to the navigation pane on the left side of the screen and select the Macros option. This will display a list of all the macros in the database. Double-click on the macro you want to review. This will open the macro in Design View. In this view, you can see all the actions and conditions that make up the macro. You can review each action to ensure that it performs the intended task and that it is configured correctly. To run the macro and test its functionality, click the Run button in the Macros tab of the ribbon. This will execute the macro and perform all the actions defined within it. If you encounter any issues or errors while running the macro, you can use the debug mode to review the code and identify the problem. To exit the design view of the macro, click the Close button in the top right corner of the screen. By reviewing completed macros in Access, you can ensure that they function as intended. Additionally, you can use the insights gained from reviewing completed macros to improve future developments with your overall programming skills. These are big steps are mastering relationship databases. Understanding macro code. Figure 1469a shows how to add code to an event procedure. Although there is a steep learning curve for understanding the syntax, its applications are unlimited. In this example, we want to create a message box that will appear when a user opens the form. The code is written out just below the comments shown in green in Figure 1469b that were added. Whenever you add new code, either directly or by using a macro, be sure to include a comment. If there is a problem or a future need for a change, comments can help clarify what the code was designed to accomplish. A. Code Builder is selected from Choose Builder in the customer order form. Property Sheet displays tabs for format, data, events, other, and all. B. Computer Code is displayed for customer form. Figure 1469a. Using the Code Builder tool, you can write the computer code to perform specific actions in Access. B. The Code Builder tool adds in the specific requirements for the computer code to work, such as and commands. Used with permission from Microsoft. After opening the Builder Options menu, select Code Builder. This will open a new window, as shown, that will allow the developer to type in the desired code directly. This code can be broken into 4 sections. First, MSG box has been identified as the action. Because it is placed in the event procedure on open, a message box will appear when it opens. Second, text for the message box in this example, ask how they heard about us, is included to remind associates to ask the customer this basic engaging question while taking a new customer order. Finally, there is a request for which form to open after the message box appears. The following message box shown in Figure 1470 was created through the code. Main menu screen opens to a new customer pane with Ask How They Heard About Us, with an OK button at the bottom right. Figure 1470 message boxes can be added to forms to give users specific instructions. Used with permission from Microsoft. Understanding Visual Basic. Visual Basic for Applications, VBA, is a programming language that is integrated into Access, allowing you to create custom solutions for data management, reporting, and other tasks. VBA provides a powerful set of tools for developers to create robust and scalable applications within Access. Some examples of how VBA can help developers in Access include automating repetitive tasks. With VBA, developers can create macros and scripts to automate repetitive tasks, such as importing data, running reports, or updating records. This can save time and reduce errors by eliminating the need for manual data entry. Customizing user interfaces can be written in VBA and can be used to create custom forms and dialog boxes to provide a user-friendly interface for working with data. Developers can add buttons, menus, and other controls to simplify complex tasks and make the application more intuitive. VBA can also create custom functions and algorithms for analyzing data within Access. Developers can create advanced data models and calculations to help gain insight data. One of the keys to VBA is opening up the ability to integrate with other applications. It can be used to integrate Access with other applications, such as Excel or Outlook. This allows developers to create custom workflows and exchange data between applications. VBA can be used to create custom reports within Access, including dynamic reports that update based on user input or other data sources. In summary, VBA is a powerful tool that seems to offer endless abilities and functionality in Access. It provides a wide range of features and capabilities for creating custom solutions to meet the specific needs of users and organizations. With VBA, you can automate repetitive tasks, customize user interfaces, enhance data analysis, integrate with other applications, and create custom reports, and that is just scratching the surface of possibilities. Link to learning. Using VBA will take some practice as you are essentially writing computer code. VBA has a wide variety of applications to assist you in working Access and also in Excel. Most users can record macros to meet most of their automation needs in Access. However, if you have more advanced needs and are familiar with computer coding, VBA can be quite powerful. The best way to show how VBA can expand the power and agility of Access is by providing a demonstration. Please view this video tutorial on how to use VBA to create databases within Access to learn more. Learning objectives. By the end of this section, you will be able to integrate data from outside sources, export data from Access to other applications, build a form to serve as a dashboard that is updated automatically. Now that you are comfortable with building and maintaining databases, it is time to start talking about integration. Suppose you have one database that controls all accounting functions and another that simply focuses on operations. Integration allows you to share information between these two databases to provide comprehensive information about the company. The simplest way to bring data from one Access database into another is by copying and pasting. However, this method does not support the updating of information, but for better control and flexibility, you may want to use importing and linking instead. When you import data from one database into another, Access creates a copy of the data in the destination database without altering the source. During the import operation, you can choose the objects you want to copy, control how tables and queries are imported, and specify whether relationships between tables should be imported. Relational databases have many layers and details baked into the cake. Making sure the details are captured is important. You may want to import data to create a table or tables that are similar to tables that already exist in another database. You may want to copy the entire table, or you may just need to import the table definitions so you can avoid the need to manually design each table. When you import only the table definition, the fields and field properties are copied to the destination database, but not the data in the table. The result is an empty table, which you can populate with your data. If your goal is to add records from one database to an existing table in another database, you should consider importing the records to a new table and then creating an append query. You cannot append records to an existing table during an import operation. Integrating data from outside sources. Data stored outside the current database is called external data. External data may be data that you store in another Access database, or it may be data that you store in a multitude of other file formats. The first step in bringing outside data from Excel or other applications is to prepare the external data. An administrator may need to create an account and provide permissions to ensure that the right people have access to the data and that the data does not end up in the wrong hands. For example, employees' confidential information must be kept absolutely confidential. In an external database, the administrator may also want to create specific tables, views, queries, and so on to limit the results to only what is needed. Access provides a powerful and effective means of presenting data, even data from external sources. When you access external data, you can either import the data into an Access database or you can link to the data from an Access database. Importing the data, though optimal, is not always possible. If you can't import external data, you should link to external files because Access maintains information about these linked files that will optimize performance when manipulating the external files. Importing data. The first step is to decide what you want to import and how it will join with your existing data. Normally, data is stored in various formats, files, and locations, which makes it hard to get and use it. If you have data in a spreadsheet, a SharePoint list, or some other format, you can import it into an Access database with just a few steps, making it much more easily available in Access. On the External Data tab, there are a number of tools for importing and linking to data in the Import and Link command group, Figure 14. 71. External Data tab is selected and Import and Link command group offers these options. New data source, saved imports and linked table manager. Figure 14. 71 data may often be stored in other programs but can generally be imported into or linked to an Access database. Used with permission from Microsoft. Linking to external data is quite different from importing data. Linked data remains in its native format. By establishing a link to the external data, you can build queries, forms, and reports that present the data. Once you have created a link to external data, the link remains permanently established unless you explicitly remove it. The link table appears in the navigation pane just like any other access table, but with a different icon. In fact, if the data source permits multi-user access, the users of an application can modify the data, just as users of applications written in the data source's native database format are able to do. The main difference between a linked table and a native table is that you cannot modify a linked table structure from within Access. There are two circumstances in which you should import, rather than linking to external data. If you are migrating an existing system into Access, if you want to use external data to run a large volume of queries and reports, and you do not intend to update the data. In either case, you would choose the import option because it gives you the added performance that native Access data provides. Steps for importing. Now you are ready to take the steps to import data from another source. Often, data analytics seems to grow in Excel. More and more, we see far too much data being stored in Excel. Luckily, the following steps can help move the data into Access for you. Open the database into which you want to import objects. You will only be able to import tables and queries from other Access databases. You can't import forms, reports, macros, or modules. The location of the import wizard will vary slightly depending on your version of Access. On the External Data tab in the Import and Link command group, click New Data Source, Figure 1472. Follow the wizard directions to add the imported records. New Data Source button is selected and opens to these options: from File, from Database, from Online Surveys, and from other sources. Figure 1472 Access can accommodate importing data from a variety of different sources and file types. Used with permission from Microsoft. As an example, suppose that once a month your local distributor sends you an updated list of wines to sell at your restaurant. The distributor emails you an Excel file that includes both the updated list of names of wines and their updated prices. The wines listed will not change often, but the prices will reflect supply and demand changes in the industry. Because the list is extensive, it will be helpful for you to know how to import the list into Access and then how to make changes as needed. You will need a table that contains both its own product ID and a corresponding stock number, the number the distributor uses to identify each type of bottle. Figure 1473 shows an example of the Excel sheet a wine distributor might send. Data file with headers for stock number, region, wine, vintage, and price is visible. Information populates the cells. Green triangles are located at top left of all cells in the vintage column. Figure 1473 data is often contained in Excel spreadsheets that might contain formulas or links to other spreadsheets. Used with permission from Microsoft. In this example, start by adding a new data source from the saved file on your computer. The Import Wizard dialog box will appear, asking several questions to help you import the Excel data. Figure 1474. Rather than just importing the Excel sheet, you can go ahead and link the sheet, knowing that the distributor will update the Excel sheet continuously. Button for Link to the data source by creating a linked table is selected in response to specify how and where you want to store the data in the current database. Figure 1474 You can import data into the database you have open as a new table currently, or you can instead link it to an existing table. Used with permission from Microsoft. After the link is made, a permanent object is created in the All Access Objects list. The example shown in Figure 1475 has the wine list table from Excel linked. It will automatically display any changes that have been made to the Excel file. The Excel table that is now visible in Access is easy to work with and functions much like a table. A wine list file is selected from Table in All Access Objects. The file open at right displays column headers of stock number, region, wine, vintage, and price, and corresponding information in cells. Figure 1475 The imported data file looks very similar in format to the Excel spreadsheet using the column titles. Used with permission from Microsoft. Link to learning. One of the challenges of managing and analyzing data is understanding what to do when data contains errors. Read this article discussing data cleaning and what to consider when cleaning data to learn more. It will help you understand the importance of cleaning data as you plan your future data projects. Exporting data. To export data from Access, first select the table or other database object to export in the navigation pane. Click the External Data tab in the ribbon, and then click the button in the Export button group for the file format to which you want to export the object. This will open the export wizard for the type of export you want to perform. The specific steps shown in each wizard will vary slightly, depending on the file type to which you are exporting. In most cases, you must select a name and file location for the exported object. You also often need to set additional parameters for the export routine. You will be prompted to save your export routine, if desired. The Export wizard enables you to export data from an Access database to a file format that can be read by Excel. When you export data to Excel, Access creates a copy of the selected data and then stores the copied data in a file that can be opened in Excel. If you copy data from Access to Excel frequently, you can save the details of the export operation for future use, and can even schedule the export operation to run automatically at set intervals. Typically, your department or work group will use both Access and Excel to work with data. You store the data in Access databases, but you use Excel to analyze the data and to distribute the results of your analysis. As another example, you may be a long-time user of Access, but your manager or another colleague prefers to work with data in Excel. Building a dashboard with navigation forms. Dashboards provide a visual interface for users to interact with when using forms. The dashboard provides a listing of buttons that direct the user to specific forms or reports. The first thing you see on opening many Access databases is a dashboard, a form populated with navigation forms that will be accessed through clicking on the specific command button. Using these provides the means for the user to navigate the database, opening forms, reports, and so on. The key for the user is a way to navigate. Traditionally, a dashboard is a graphical interface that allows a quick view of visualized data, as shown in Figure 14. 76. In Access, however, we can build a dashboard from a form that will let us easily run queries and pull up reports. This section will demonstrate how to upgrade a main menu form that has only buttons and labels into a full dashboard of information for your company to use. A main menu window displays white buttons for new shipment received, current customer history, and new customer order in the middle of the screen. Figure 14. 76. A dashboard is a menu of buttons that allows users to access other forms and subforms that you have created. Used with permission from Microsoft. Planning your dashboard. There are 4 general subtypes of dashboards. Strategic dashboard, focused on long-term strategies and high-level metrics. Operational dashboard, shows shorter time frames and operational processes. Analytical dashboard, contains vast amounts of data created by analysts. Tactical dashboard, used by middle management to track performance. In the following example, imagine that you are a mid-level sales manager who wants to track a basic sales summary. A tactical dashboard seems like the best fit for your situation. Business intelligence has evolved into smart solutions that provide effective data management. From extracting, monitoring, analyzing, and deriving actionable insights needed to stay competitive in the market, to powerful visualizations created with a dashboard builder, which enable business users to interact with the specific bits and pieces of information they may need at any time. In this simple example, you want to record and track total orders and number of customers. Adding these elements to your main menu is a good place to start building your dashboard. It is often helpful to first make a listing of the forms that will need to be regularly accessed by users. The forms could vary by department, but there might be a group of forms that are routinely used company-wide. At WorldCorp, key performance indicators, KPIs, are critical to monitor for the success of their strategies. A dashboard that contains navigation options as well as KPIs can help manage the business. Figure 14. 77 shows an example of this. Main menu window displays buttons for new shipment received, current customer history and new customer order, a sales summary with orders and hash of customers, and bar graph with date and sales. Figure 14. 77 dashboards can include not only navigation buttons but also summary information for tracking purposes, used with permission from Microsoft. DSUM and decount expressions can add both a sales total and a customer count to your dashboard. These have been added to text boxes that were unbound to the form. Each text box was then formatted to fit the theme of the form. Under Form Design, Insert Modern Form was selected. This is a simple yet powerful way to add context to a sale. Additionally, your team can review the form and see the results as they are updated after each launch of the form. Note that there is an option to refresh all on the Home tab, which will update the text box and charts. Real-world application. Relational databases in the cultural world. Many industries use relational databases. They are often hard at work in the background compiling data, gathering customer information, optimizing inventory, or organizing content for decision-making. Database usage is more evident in industries such as banking, airlines and transportation, manufacturing, and retail. In recent years, the usage of relational databases in unexpected industries has surged. One example is in libraries and historical preservation. Libraries and museums have utilized new technologies to make their collections of archives and artifacts available digitally for a much larger audience to enjoy, appreciate, and use for their own research. Wilmington College, a 4-year liberal arts college in Ohio that was founded by the Religious Society of Friends Quakers, has done just that. Through the generosity of a significant peace activist and donor to the institution, the college has an extensive collection of artifacts related to Hiroshima and the impacts of nuclear weapons held at its Peace Resource Center, PRC. The PRC Archives is the most extensive collection of interdisciplinary materials related to the legacy of nuclear war in the United States. Each year, the PRC BRMA receives between 400 to 450 visitors, including researchers, students, and members of the public. The archives holds documents, creative responses to the atomic bombings such as poetry, plays, and artistic works, historic poster collections, historic photos, slides, scrapbooks, photo albums, 16 films, reel-to-reel audio, cassette tapes, and artifacts, among others. The Barbara Reynolds Memorial Archives. Through the use of digital archiving and cataloging in an extensive database, this collection is available online to the broader public. The searchable relational database is linked to several research libraries and contains digital images of the archives and artifacts held in the college's collection. Many other such databases of items of historical significance exist across the world, such as through the Smithsonian and the United States National Archives. Historians and archivists have taken advantage of these technological tools to make history more accessible without compromising the integrity of the artifacts.